It basically means that genes from animals can be transferred to humans to cure certain diseases. Not necessarily diseases, but disabilities as well. When I first saw it, I was amazed. Was that amazing? Spectacular.
I don't know, I didn't try.
Let me show you a couple of examples regarding this. Before I do that, I just want to say that what is it and what to propose is not scientifically proven, but it's definitely the future proven. So first is a cure for Parkinson's disease. Those who love Muhammad Ali might be interested. My beloved brother Abdurrahman Jali, he's the biggest fan of Muhammad Ali, a former American boxer who was diagnosed with Parkinson's disease back in 1984. Yes? Yes? So yeah, this is one famous figure who has Parkinson. Another is Sir Faisal, the foreign minister of Saudi Arabia. He also suffers from Parkinson. If you haven't seen him giving a speech, he always goes like this. He keeps moving his neck. He's also having difficulties in standing upright. He was bending, which are some manifestations of the disease, which is very popular. It kills the quality of one's life. There might be a cure for such disease. Well, if we're talking about a cure, as you may know, a person gets Parkinson when there is a decreased secretion in double cells resulting from the degeneration of the dopaminergic neurons, the area substation idea. A zebrafish has the ability to regenerate cells on command. If this ability is somehow taken to human, regenerating the bone cells and eventually curing Parkinson's disease once and for all. This is one example. Another is this slide going on. Limb regeneration. Lizards. Beautiful creatures, aren't they? Lizards, colorful, wonderful. I mentioned that there's a colorful food now. Lizards, they have the ability to regenerate their tail when it's cut off, sort of a survival mechanism. Now, in that movie, they were claiming that these genes that encode for tail or limb regeneration can be inserted to humans, so human beings can regenerate an entire limb if amputated. Now, I know as much as you do that today these are nothing but stories to produce a movie. But tomorrow, this could be reality. Medicine is developing. Biotechnology is developing. This could be possible one day. Someday. Now, in conclusion, we've discussed the idea of rDNA, how two DNA fragments are combined to create a new sequence. That could be a new protein product or even a new trait, for that matter. And we've seen its application in genetic diseases such as sickle cell anemia, cystic fibrosis, diabetes, or who knows, maybe take them to a whole new level, limb regeneration one day. Thank you so much. Any questions?
How to create an rDNA?
How to create?
A recombinant DNA.
How to create a recombinant DNA?
Yeah.
You mean the laboratory? You mean how to do it to the lab? Okay,
yeah.
Okay. More of a practical question. You see, the idea of rDNA is simple, theoretically simple, but practically not as much. It costs, it needs time. See, first step is if you want to create a rDNA, first step is obviously you need to extract that DNA. DNA extraction is a whole different story. I'm not getting into that. Dr. Is it here? Dr. Ali Imran, I believe his name was. He was nice enough to walk me through the devices and instruments used to extract a piece of DNA. Let me tell you something, that was a lot. You can't even imagine how complicated the process is. And even if you get that DNA extracted, it's only valid for like 1 week. Then it can no longer be used. So yeah, it's some serious stuff. I'm not getting into it, but let's just assume that we've extracted both DNA fragments. The plasmid DNA, then they will be used as a vector, and the foreign DNA, the one that contains the gene that we want to become into recombinant DNA, okay? Now, a couple of enzymes are used in this process. First enzyme is called restrict. Would you like to show you a video that illustrates how this is done?
Okay.
Videos are always nice, my friend. They illustrate the idea more than word, and people love it. I'm taking way more time than I should, but please let me show you this. This is. Oh, sorry. Let me just show you this. So I was saying, the plasmid DNA and the piece of DNA we're interested in, right? Let's have a look at the plasmid DNA first, inside. Now the first step is to cut that DNA. The cutting of the DNA is done by an enzyme called restriction enzyme. What this enzyme does, should show in a minute now, yes there it is. What this enzyme does, it locates and cuts the DNA at very, very specific sequence. It locates a specific nucleotide sequence and cuts it whenever it finds it, leaving unpaired DNA fragment, or what is called sticky ends. Now this same enzyme is used in, let's say, an animal DNA to extract that piece we're interested in, right? Which is the one in blue, right? Where is it inserted into the plasmid DNA where bonding occurs between the two DNA fragments? The enzyme DNA ligase facilitates the connection, right? Creating what we call recombinant DNA molecule, aka plasmid vector, aka chimera. This plasmid needs to be transported into a host cell, another fresh bacteria, right? Once inside, it undergoes mitosis. The DNA replication takes place, and it keeps replicating, and replicating, giving thousands of copies of that newly inserted DNA, and eventually giving the gene product. That's how we create our DNA. But let me tell you something, one last thing. You see this 2-minute video? This is the old way. This is an old-fashioned way. I have an enzyme to cut that DNA, an enzyme to connect that DNA. It takes time, especially when you're in the 21st century. Guess what makes things easier? Polymerase chain reaction, PCR. It can do all that. We just put the systems in, close it, set it up, and there you go. We will cut, connect, and give the gene product eventually. PCR is revolutionary device, a technological breakthrough in science, which proves what I said a couple of minutes ago. Medicine is evolving. I'm sorry, I took more time than I should. Thank you so much for this.